All right. For those who are here, welcome to PadNug April 2020. It's going to be fun. This is our very first time ever doing a PadNug completely virtual. So I'm sure there's going to be a few surprises and learning opportunities, but I think we'll have a good time. Mario's going to be our presenter. He's up in the Redmond area, I guess, but it doesn't matter. Most of us, I think, are in the Portland metro area, although I know that there's people in Washington and other places. I see Luke Hammers. Yeah, there you go. Luke had his back toward the camera and disappeared into the background. That was a good time.
Sorry about that.
No, that was fun. That's the best part. I'm going to be totally distracted while I'm trying to present here, watching everyone else do stuff. So I do have this recording, so presumably we will be able to post it up on our YouTube channel when we're done. To be determined, since we've never done this before. I am suggesting that people, there are still several people who have just a first name or other descriptors. I do suggest that you put your full name on there so we know who you are if and when you raise your hand or have some feedback to provide. So Danielle, you've gone all the way, including your company name, which I think is ideal for this. And especially for our supporters like Danielle, I think that's going to be perfect. Obviously, you won't be able to mix and mingle if you want to talk to one of the recruiters. I'm going to ask the recruiter staff, including Danielle, Alina, Andrew, etc. Put your contact information into the group chat and make it available to everybody so that they can reach out to you outside of this meeting. However, during the meeting, if the person you want to talk to is on here, you can also chat directly to that individual. If you open your chat window, you can send a message to a specific individual. On that point, I really recommend everyone have your participant list and probably your chat window open throughout the presentation. That way you can raise your hand on the participant list, and you can also chat up individuals throughout the presentation. I'm going to generally mute everyone because we don't want noises from the background and all. However, I'm going to be watching the chat window and participant list. If someone has a question, they can do the raise hand, and we can get to it as soon as Mario has a moment's break. We don't get pizza this month unless you got your own. Did anyone bring their own pizza? Just curious. No, don't see any. Excellent, Alina. Alina has put her email address into the chat window already. With that, I think we'll get started. As usual, here are the places to find PadNug, if you don't already know. The reason we meet every month is Microsoft came up with a little thing called .NET almost 20 years ago. We are still a .NET, technically a .NET user group. However, there's so much other stuff we do, I tend to not call a lot of attention to that in general conversation. I left Intel on here, although we're not meeting at Intel tonight. Everyone knows they provide space for us to meet every normal month, and that is exceptionally wonderful to have. Once in a while, you may notice me pause for a second while I let someone into the meeting, by the way. Now, IT motives, you're at the top of the list at the moment, Alina. How about you go ahead and put your plug in?
Hi, everybody. Thank you for making this available via Zoom. It's super good to stay connected, even if it's only on video chat. My name is Alina. I'm with IT Motives, small, mighty recruiting company local to the Portland area. My information is in the chat room, so if you have a need, please feel free to contact me. Or if you just want to have a Zoom meeting, you know, have a glass of wine and catch up. I'm here too for that.
Alina, since you mentioned it, since you are doing this from home, you can enjoy beverages while you're on the
Oh,
Zoom.
look at this. You see that?
Right?
I've got my wine. I've got my wine.
Now you are still responsible for your behavior on the Zoom meeting.
Okay, all right. It's documented and recorded.
Okay, well then let me go on. Danielle, Tech Systems.
Hey, Rich. Hey, everybody. Good to see everybody. I miss everybody. We still have several clients hiring, and you know, in these uncertain times, it's more important than ever to think forward for your career. Never hurts to, you know, talk to somebody like me or Alina or Andrew or really any of us about, you know, what you really want for your future. So contact me. I'll put my thing in the chat, my contact information in the chat in a moment. But, you know, everything that we're hearing, we're happy to share it with you about the Portland market and what careers are happening. So good to see everybody.
Thank you. SoftSource, is anyone from SoftSource on the call today? Even though I don't work there, I'll go ahead and give them a plug. As most people probably here at PadNug know, I did not leave SoftSource for any reasons. I just had an opportunity that I wanted to explore. I really enjoyed my time at SoftSource. As of the last I knew, they were still hiring, and I doubt that that's changed. So if you can contact me if you'd like, and I will provide contact information for you there. Wade or Charlie, are you on the line? I see a Charlie. Is it the right one? No. Okay. Robert Half. I know Stephen Gregor's out there.
I am here with my Doom background here. Hey, everybody. It's Stephen with Robert Half Technology. As most of you know, we staff for IT positions here around Portland. We're the world's oldest and largest specialized staffing firm. And despite everything that's going on, we're still always looking for people to come on board for either temporary projects. And we also have a direct hire team that's killing stuff right now. So you know how to operate a computer, and you want to look for a new job, or you're looking for a job, or you just want to kind of poke around, see what's out there. Let me know after this. My contact information is in the chat. We'd love to show you around and, you know, introduce you to a few people, and talk to you soon.
Excellent. And by the way, everyone, Stephen is a member of the Commodore 64 group too. Mr. Andrew, I believe it must be your time.
I guess so. This is kind of an interesting way to do PadNug, but I'm game. Yeah, so I'm with Vanderhouen. We've been doing this in Portland for a long time. Coming here to PadNug for a long time as well. We place software engineers like yourselves around Portland, and we work with a lot of companies here locally and have been for 30 years. You know, it's very slow out there right now, as everyone knows, right? It's kind of uncertain, and, you know, it's not a very fun time for a lot of us, but we are still hiring. We have a few right now for .NET developers, you know, south of Portland, in Portland, in Beaverton, and I'd love to chat about it if you're up for that. Feel free to hit myself or Taylor up, or any of you know, Danielle or Alina or whatever. We would all love to chat with you. And even if it's not for right now, we can catch you next time.
Yeah. Thank you, folks. Let's see. You know, I'm kind of surprised. No one has thrown any more ideas on podcasts we should be advertising here. Whoops, that was me. So the same three are there since we started this.
There's a new one that's actually worth mentioning. It's the .NET Core podcast. It's I can't remember the gentleman's name now, but he's from the UK, and I've been listening lately, and it's quite good. So the .NET Core podcast.
Would you be so kind, if you get a moment, to throw it up there in the
You
chat?
expect me to be kind to you? Sure, I
No.
can do.
No, I don't expect that. It's kind to the group.
I can manage that.
Excellent, thank you. Seems appropriate. By the way, I don't know if anyone saw, but Mr. Franklin, after finishing his road show much earlier than expected here in Portland, has turned the rest of his road show into a desk show. So he's continuing the presentation from his desk in that town he lives in. I can't remember it all of a sudden, but yeah. And I don't know if anyone else saw, but he actually apparently tested positive for corona this last week. He posted that publicly. So go ahead and go listen to him once again. Mike, if you didn't get to see him when he was in town, that might be a chance to do it. Or if you just want to see the content once again, go for it. Oh, before I get too far away, Rachel, I want you to say something too. Rachel's with New Relic, and I know her husband already, and we were just chatting about some needs they have at New Relic. So go ahead, Rachel.
Yeah, hi. I'm not a recruiter. I am just a product manager.
Yes.
But I have a full stack team that we're hiring, I think 5 software engineers for, and we are aggressively hiring from many other teams as well. So definitely if you're looking for something, even if it's a Portland office that you're interested in, I'm sure we'll reopen our office someday when the world is back to normal. But we also support remote work. So if you're in a different city, that's fine too. If you're interested, go ahead and reach out to me.
Excellent. Well, and it's cool because you'd be on the same building I'm in too. So I'm sure you'd have a good time there, folks. And Rachel,
Yeah,
I'm pretty sure.
but it's big. So
Yeah.
if that's not positive for you, there's plenty.
Oh, ouch, ouch. My new friend's already shooting my arrows.
So you have lots of options.
Also, I think I saw your contact info up there too.
It's in the chat. You have my email. My LinkedIn is just Rachel Knotts.
Cool. Thank you very much.
Yeah, thank you.
And Hunter is sharing some podcast options too, if anyone's not looking at the chat. So what's coming? I've noticed something that most of the user groups that we used to share their upcoming meetings with have kind of faded away, and I don't know where they're all going. There's probably 8 or 10 that just haven't met in months now. So, and of course, this current situation is probably changing it even more. However, tomorrow night, apparently Oregon Data Community, formerly the Oregon SQL Group, is having a meetup, and it is supposed to be virtual. PadNug, we did have a virtual geek dinner last month, 2 weeks ago, and it went off pretty well. So if people are interested in doing that again, I'm happy to schedule it. Then on April 24th, Agile PDX is having a virtual meetup. And I particularly wanted to capture that one because keeping remote teams connected seemed like a very relevant presentation to see this month. So I threw that on there too. Then April 26th, Portland SQL Server User Group, they're planning to have a virtual meetup too. They don't have a subject yet. Likewise, on the 28th, we can do a virtual geek dinner if people are interested. And then finally, is it coincidental that Jeff Doolittle turned off his video right before I got to his name? Anyway, Jeff Doolittle is going to be presenting next month REST Rex microservices. Go ahead and tell us a little bit about that, Jeff.
Oh gosh, you didn't give me fair warning.
I did.
Well, the title's intentionally provocative just to get people maybe to, I don't know, want to pick a fight.
I absolutely love the gist of the presentation that we've discussed. So
yeah, it's really, it's going to go into a lot about infrastructure. How do we properly decompose our microservices, and then how can we make sure that we're not coupling ourselves to infrastructural decisions and technology decisions that are going to keep changing over time. So, you know, you could jump from REST to gRPC and get just as coupled to that as you were to REST. And you could end up with endpoint proliferation regardless of your technology, which isn't necessarily REST's fault, although we see it like crazy right now, where clients are coupled to the backend APIs, and then every time you need to do a new communication as a new endpoint, you just get this nasty proliferation going. So getting out ahead of that, thinking about how we create APIs that are a lot less constantly changing whenever requirements change and there's new things we have to do. So yeah, we'll be talking about how REST wrecks microservices and how you can avoid wrecking yours.
Excellent. Thank you, sir.
Yep.
Well, normally after this, we'd just probably move on to the slide that shows how to get to Thirsty Lion for everybody. Unfortunately, that's not happening tonight. So as I mentioned earlier, if you want to have a beverage or a snack during the meeting, feel free. Just be responsible and make sure we don't publish a video with you doing embarrassing things. So with no further ado, Mario, I think we're about to put you on the spot here. Once again, I'm going to mute everyone else, or mute yourself if you'd be so kind, and then raise your hand or just chat up in the chat section if you have a question for Mario, and we will get to you as soon as possible. Thank you, everyone, and Mario, it's your turn.
Hey, can everyone hear me?
Indeed.
Awesome.
Well, at least one person can, I should say.
There was some weirdness going on the screen right here. So let me see if I can. No, I can't. So I got some technical issues going on right now. Let's see here. All right, now that might work. So let's try that. Sorry about that.
Ta-da.
Are you able to see my screen?
I can see your screen.
Awesome. So thanks everyone for, I was going to say coming out, for joining us virtually this evening. And also a big shout out to Rich and the organizing team for switching this over to virtual in these, I guess, turbulent, really strange times that we're going through. What I'm going to be talking about today is .NET Core debugging for Windows and Linux. And couple of logistics before we get started. Q&A at the end. I usually like to keep sessions interactive, but because we're still kind of getting used to the virtual thing, that I would just ask if we can kind of keep them at the end, or if you want, just put them in the chat window, and then we can address them once the talk is over. So with .NET Core, we obviously got, we got Mac, we got Windows, we got Linux, it's cross-platform and all this good stuff. And when I was kind of preparing this presentation, I was thinking about the best way to demo some of these things. And I settled on just doing it on Linux, right? I would venture a guess that a lot of us are coming from possibly a kind of a .NET full background off of Windows. And so I wanted to focus on showing what it looks like on Linux. So I'll be running Ubuntu 18.04, LTS, and in my particular case, I happen to be running it in WSL2, but you could be running it in VM or bare metal, whatever you want. In terms of prereqs that are assumed, this is going to be about production debugging for .NET Core. So there are some prereqs that are going to be assumed. We're not going to be talking about Visual Studio, even though Visual Studio has a great debugger. It's got a lot of fancy features in there. This is more about like I'm running my .NET Core app at scale in production. What tools are available with least amount of intrusiveness that you can get, and based on those tools and what it collects, how could I get to root cause? There are some other prerequisites because it's kind of at a lower level than Visual Studio. So few examples of prereqs, right? You got to know what a obviously process is. You got to know what a thread is. You should be familiar with the notion of like memory dumps or crash dumps, what they call on Windows, core dumps on Linux. You don't necessarily have to know how to navigate all the aspects of a core dump, but just the general concepts. What I'm going to show is sort of how it's different from what you may be used to on .NET Full on Windows versus running .NET Core on Linux or Windows or Mac OS. What I'm not going to show is sort of the similarity. So we're going to focus a lot of our time on what tools are available to collect the data that you need off a production server so that you can go back in postmortem and analyze that data. We're going to be focusing on the collection part of it. So we're going to be at times looking at tools like Purview and other things. I'm not going to go into a lot of detail about those tools in particular. It's just that collection piece. How do you get that data off your production machine, right? So let's talk a little bit about what are the differences. If you're looking at the things that you may have been used to on .NET Full on Windows, which versus .NET Core on Linux or Windows or Mac OS. So there are quite a few differences. Obviously, it's all cross-platform, so that's a great thing. But if you're used to Windows and .NET Full, what you may be used to then is a fairly large ecosystem of tools that works on production level diagnostics. So we've got the notion of WinDBG, which is essentially, should I call it, a low-level debugger. We've got Sysinternals tools for Windows, like ProcDump. We got Debug Diag and a plethora of other tools. So the ecosystem is fairly broad. On Linux, we have the tools that we need to get the data out, but the ecosystem around like analysis and things like that may not be as mature yet. Now, the good news is that it is being worked on, and so the gap between Windows and Linux will be or is closing rapidly. So I'm not going to bore you with a whole lot more slides. We're actually just going to be doing things in the sessions. And as with sort of any type of production diagnostic sessions, you kind of have to hone in on what are some of the conceptually, like what are some of the most common scenarios that actually occur in apps. And there is a plethora of like, for each of these categories, there's a plethora of different root causes and things like that. But in terms of symptoms, two of the most common ones is my app is running slow. What's happening? Or my app is crashing, intermittently or not. What is happening? So those are the two things that we will be covering. I apologize. That's my phone alarm. So we're going to be going through scenarios that's going to be talking about specifically what you do in each of those cases. And I'm going to be showing you actually running some sample apps. Last slide before we get into the actual demos. Let's review the high-level debugging process. Something is happening in production. Perhaps all you know at this point is that, I don't know, users are calling in. They're just saying stuff isn't getting processed or it's taking too long to process, whatever the case may be, right? So you go through the triage process, part of the process. That's when you start kind of honing in and seeing, if you look at the system overall, which piece seems to be the one that's failing, right? Once you've kind of honed in on that part of the overall architecture and which piece might be failing, that's when you start thinking about what data do I need to collect to be able to actually root cause this problem. Once you have that data, that's when you go into the analysis phase. And in the analysis phase, in best case scenario, you might be looking at a few different pieces of artifacts. In worst case scenario, you're looking at a ton of them and trying to piece things together to figure out the root cause. Once you have the root cause, you then immediately go into the fixing stage, right? You want to make sure that the problem is fixed, you get it deployed, and everything is just looking awesome. There's one other thing in this process that some of you might be going, it's missing, and that's the mitigation phase. So oftentimes when mission critical systems go down, for whatever reason, as an engineer, you're obviously extremely curious to figure out what is wrong, so you can go through this entire process and get things collected, you get things analyzed, you get things fixed, right? But sometimes you can't afford that, especially in a production environment, in the sense that the business might be knocking on your door going, we're losing hundreds of thousands of dollars because of this, let's just mitigate it, right? And so what you end up doing, I mean, just an example, you restart the server, right? Server comes back up and is happy again. Now, is it going to fall over again? Probably. Is it 3 days from now? Is it a week from now? Is it a month, six months? Who knows, right? And so even though you might feel pressure to mitigate by restarting, once you've done that, the problem, doesn't disappear, and the business will be at you again, saying we can't afford this to happen again. So therefore, can you tell us what's wrong and fix it? And that's where it's really, really important. These two phases that I've kind of put in bold here, is that in the face of having to do a quick, super fast mitigation to save money, you still need to be able to understand how to collect the data in that very short time window, so that once the mitigation occurs, a restart, whatever the case may be, you have that data post-mortem to go and look at, and then be confident that you have a fix for something that's been mitigated in half an hour, or some very short time span. Okay, so with that, let's take a look at some of these scenarios. First one is my app is running slow. We see that all the time, right? Everything is running fine in production, and all of a sudden the app starts slowing down. Maybe it's because of increased load, which especially in today's environment, I guess the unfortunate environment that we live in, we see that all the time, right? People are relying a lot more on online services. And so the capacity planning that perhaps has been done for apps is not holding true anymore. So my app is running slow, and what can I do to actually figure out to troubleshoot that? Is it just the fact that we're running a lot hotter because of load, or is it because the increased load has surfaced a bug that we need to figure out, what's going on there? So with that, let me see if I can work this thing. I'm hoping everyone can see this. Let me zoom in just a little bit. Again, I am running WSL2 on Windows, just Ubuntu 18.04 LTS. There's really no magic there. You could run this, on a VM or bare metal, whatever you want. So I've got an application here, .NET Core app, and if we run this thing, if I could spell, that would help. There we go. Essentially, all this does, it simulates a server or service running on this box. And for each request, it is running the, it's honoring the request, and is looking like it's taken, I don't know, looks about 3 seconds for each request. Now, we think that that is probably not an accurate thing. Like, we don't expect it to take 3 seconds. As a matter of fact, we in a normal state, we expect it to take sub 1 second. So something is going on with this app, and it's running in production, .NET Core, what do we do? So with a lot of the sort of quote unquote slow running processes, what tools do we typically use, right? It would be in the shape of a profiler of some sort. And the profiler, what all it does is basically sits there and profiles the application that is then capable, based on that profiler trace, to show you what is happening within it. So do we have something like that for .NET Core? We know we do for like .NET Full on Windows, but do we have something like that for .NET Core? So let's see if we can debug this thing. By default, on a production server, you'll likely have, the .NET Core runtime installed. It is how this app is running right now. If you want to get the profiler capabilities, you're going to have to install another tool on the prod servers. And the tool is called .NET Trace. And the way to install that is just to run .NET tool. Let me scroll. Sorry, I forgot. There we go. .NET tool install global and the tool name, which is .NET Trace. Now I already have it installed, so that's why it's giving me that error, but it is a painless install. You run that and .NET Trace tool gets installed. So let's kind of take just a brief look at what .NET Trace can do. Well, let's see, .NET Trace options and some commands. So what are the versions? The commands is collect. That might be something we're interested in, right? We want to be able to collect traces off of this process or a process. PS lists the .NET processes they can be attached to. We'll see how that comes in handy later on. And then list profiles is if you want to set up specific type of profiling sessions, you can use this. And lastly, convert, we'll also talk about that a little later. And you can convert the format in which the traces are generated to something else that might be more useful to you. Or at the very least, to a different format that you can visualize in a way that you used to. So that's .NET Trace in a nutshell. Now, if we wanted to trace the process that we're currently running that we think is actually taking too long, right? Every 3 seconds. The first thing we got to do is figure out what is the process ID, because .NET Trace needs to be told what process to trace. And it's done through a process identifier, right? Just like on Windows. And the easiest way to do that is to run .NET Trace. And as you can see up here, it says list all the .NET processes that can be attached to. So we will issue the PS command. And we notice here that we've got our slow application running with the process ID of 547. So we got the process ID now, and that's all we need to start collecting. So we'll run .NET Trace, issue the collect command, process ID, it's the one we just got up here, and we see some output here, and it's basically saying we are recording traces for that application. So I'm just going to let this run for a couple of seconds. And we will hit Control-C to exit. What that ends up doing is that .NET Trace has generated a file that contains all the profiling information for that particular run. And by default, it places it in a file called trace.NET Trace. Now, for some of you This might look familiar, the NetTrace extension. And we'll see how that comes into play a little bit later. But essentially what happens is that .NET Trace has created a profiler trace of the application running and outputted a .NET Trace file, which is a perf view file. Now, perf view is a very Windows-specific thing, and you need a tool on Windows called perf view to actually open it up. So with that, I'm going to take because I'm running on a Linux box right now, or a WSL-ish box. I can't really open this file on Linux because there is no perf view for Linux. So I got to move this file over to a Windows box and open it on Windows using perf view. So let's just take trace.net trace. And now all I'm going to do is actually just copy it over to my Windows box. Now again, I'm running WSL2, so I can have all these kind of fancy mounts stuff already predefined, but it holds the same in a VM or anything else. Move the file over to a Windows box. So we copy the trace file over to Windows box, and now we can run perf view. Let's see, where do we put it? Here's the trace.net perf. And you are going to be able to use the same power of perf view on Windows with a profiler trace generated on Linux and do all the same capabilities that you can in perf view, right? Unfortunately, we don't have time to go through a deep dive of how perf view actually works, but you can see all the call stacks and where most of the time is being spent. So with that, let me see if I can move back to the presentation. If you need to collect perf data off of a process on .NET Core on Linux, then you can use .NET Trace. The default output format that it uses is NetTrace, which is perf view. So you have to copy that file over to Windows. That begs the question, like, do we really want to force Linux engineers to use a Windows box? Because if I'm looking at a process in prod on Linux, do I need to take artifacts off of diagnostics artifacts off of that box and move it to Windows? So there is another part of the story to this, and let me show you how that's done. I'm back in my terminal. I have generated my trace.net trace file, perf view file, right? But I don't necessarily want to move it over to Windows and use perf view. So what you can do is you can use the same tool called .NET Trace, and you can ask it to convert the file from a perf view file to something else. And in this particular case, what we're going to do is use something called SpeedScope. For those of you familiar with flame graphs, SpeedScope is a mechanism by which you can visualize performance data in a fairly extensive flame graph fashion. So I will simply issue .NET Trace, convert, and I'll specify the format to be SpeedScope. And all that tells me is, hey, I've written this file out, the conversion is complete, the file is available at trace.speedscope.json. It's just a straight JSON file. And I can now copy it over to, I guess we go the same place. Again, I'm running WSL2. I don't have X server set up or anything like that. So the way that you open up these Speedscope files is through a browser. Because I'm not running X server or anything like that, I'm straight in the terminal. I can't do that, so I copy the file over to Windows so I can show you. But if you're running anything else with an X server or some GUI, then you can just open up the browser in Linux. So let's go over to Speedscope. The URL is simply speedscope.app, and fairly simple. Click the browse button, find your trace.speedscope file, open it up, and it will give you pretty flame graphs in a couple of different ways that you can view them: time order, left heavy, or sandwich. And you can drill down into the things that you find most interesting. So this is another way where you can take existing diagnostics data coming out of Linux and basically not being forced into using something like Purview on Windows. Okay, so that is the summary of Speedscope. To get a Speedscope file, convert the trace file. You can actually run .NET Trace by using a format flag so that it collects in the format that it was intended, so you don't have to convert. And then you can just visualize it using the speedscope.app. So the key takeaways here is that for slow applications, you want to use .NET Trace tool to generate the perf traces. If you're on Windows, even though your app might be running on Linux, then you can just use the Purview file format and analyze it on Windows. If you're on Linux, you can use Speedscope, or here's the thing, you can write your own tools. There is kind of no magic in terms of what .NET Trace does. Like when we launch it, it's a separate process. You specify the PID of the target process that you're interested in, and somehow, in a non-magical fashion, out comes a trace file, right? The key thing there is that a .NET Core process that launches will expose this communication mechanism. On Linux, it's sockets, and on Windows, it's well, I guess on Linux it's Unix domain sockets, and on Windows it's name sockets, and it's just a communication protocol. That's all it is. So you can write your own diagnostics tool, if you will, and all it's got to kind of do is just send the right commands through that pipe, and the .NET Core runtime will do the right thing. That is exactly what .NET Trace does. It basically just calls the runtime and says, hey, I want you to start tracing right now. When you hit Control C in .NET Trace, it sends a message saying stop tracing, and out comes this file. So there's 100%, you can write your own tools. We'll talk about this a little bit more later, but when we talk about proc dump for Linux, we do that. We recognize the fact that you're talking to a .NET Core process, and instead of invoking the regular quote unquote dumping mechanisms of Linux, we actually ask the runtime to generate the dump. And we'll see how that is a little bit more efficient for .NET Core processes. Lastly, and very, very briefly, the .NET Core runtime does have a few other integration points with kind of the more established things that people might run on Linux, which is perf and LTT and G. So there is a possibility of using those as well. Okay, so we kind of cover my app is running slow, and I kind of want to pause here just a little bit and see if there are any questions around this before we move on. I guess either live or through chat. Let's see if I can bring up the chat window. I'm going to be all brave here. I don't know. I don't know.
Chance to speak, people.
There's Rich.
And there's Eldred has a question there. What was that analysis tool for Linux?
Speed scope.
And it's in browser only?
That, as far as I understand, is browser only. Now, it is a JSON file. So are there other tools out there that will take that and visualize it perhaps in a TUI, like nCursors or something like that? It's possible.
All right, I guess we can go ahead.
All right. So the next scenario, sorry, Rich, I got to minimize you here. The next scenario here is app is crashing, right? Seen that plenty of times. How do we go about diagnosing that? Let's take a look. I'm going to clear this stuff out. Go to my next sample app. I'm going to use a very basic one to illustrate the concepts. Actually, we were right where we wanted to be. Okay, so if I hit .NET run, simple console-based app, press any key to run, and it says unhandled exception, and it's of type system exception, something bad happened, right? How do we actually go about debugging this? Well, how would we go about debugging it on a normal, .NET full on Windows app? One way to do it is to attach a debugger to the process. On Windows, that's usually something like, hey, I'm going to attach WinDBG, right? And when it crashes, I can use all kinds of weird magical commands to figure out what the issue was. So do we have something equivalent on Linux? That's kind of the big question here. And it turns out that we do. There is a quote-unquote equivalent of WinDBG. It's called LLDB. And what you have to do, first of all, is install the debugger, right? The LLDB debugger. So you would use the regular, in this case, again, I'm on Ubuntu, so I'd use apt. Sudo apt install LLDB. Now, it needs a password. It's right now telling me that I already have it installed. But just as any regular apt install on Linux, if you don't have it installed, it will just go through and do it. So let's see, can we run LLDB? Whoops, one too many L's.
Mario?
Yep.
Real quickly, Chris had a question. What about if the crash is from deep step within a longer workflow?
If it's what now?
What about if the crash is from a deep step within a longer workflow? Chris, go ahead and unmute if you want to expand on that.
Maybe just like if, there's more steps to actually get to the point where the application actually crashes.
Gotcha. Yeah, thanks for that clarification. So I'll show you a little bit later ways or tools that are available on Linux where you can set triggers of when a diagnostic section needs to happen. Great question. Just bear with me just for a little bit. Okay, so we got our app here and we had LLDB installed. I'm just gonna, for the sake of my own sanity, I'm gonna run the debugger and, it says LLDB. So I'm assuming sort of everything is okay, right? Debugger is installed. Now, if we think back to Windows and .NET Core debugging, or I'm sorry, .NET debugging full on things like using WinDBG, we oftentimes use this tool called SOS, right? It's essentially a debugger extension that you plug into WinDBG, and it does its magic and translates things for you so that you can see reasonable, .NET artifacts in the debugger. Question is, do we have the same thing on Linux using the sort of quote unquote equivalent of WinDBG called LLDB? And the answer is yes, but we have to be just as particular about getting the right version of this helper called SOS down to our box that we do on Windows. And the really, really cool thing about this is that there is a tool that you have to install. So it's .NET tool, tool install global, and it's called .NET SOS. That is the tool that you should kind of memorize. When I run that, once again, I already have it installed, but if you don't, it just installs it. There's like no weird dialogues or clicking or anything like that. It just gets it installed. What this tool does is, at a high level, it brings down the right things to your box. And also it updates your LLDB, the debugger configuration, so that it automatically loads up the right things for you. So when you run LLDB the next time, what happens if we want to try some SOS things? So I'm just going to use the most basic thing, SOS help, which should tell you all the commands that are available. And it does, right? And this is literally SOS from, the thing that you might be used to on Windows. So you can run all of these commands at your leisure. So kind of at this point, we know that we've got the right debugger installed, LLDB, with this kind of cool tool, .NET SOS. We know that we can bring things down kind of automatically without having to worry about like pointing things to symbol servers and like fetching various things. It just does it for you. So with that, let's go back to see what our actual goal was, which is, how do we debug? Let's see, which window was I in? Let's use this one. I'll go back to our crashing application. Do a .NET run. And before we have this application crashed, we want to attach the debugger. So how do we go about doing that? Kind of in a similar way that we did with WinDBG. Like we have a running process. We want to attach to it. So we'll run LLDB. The command to actually attach to a running process is process attach -p, and we need the PID again. And how do we find the PID? Well, let me scroll in. There we go. How do we find the PID? Well, .NET Trace seem to have this PS command, right? Process list. Oops. And our application we're interested in is 1402. I'll move over back to the tab with LLDB, process attach PID 1402. And now we're attached to that process. So with that, what do we do next? Well, let's just try let's just try a SOS command like CLR stack. That should give us the human readable version of the call stack of the thread that's currently running. And we see this is really nice, right? We got our crash.program.main, and this just calling into readline, which we expect because the application was waiting for someone to hit something on the command line. And so we are able to use SOS to get the .NET Core specific information. I'm going to try to show you what this exact same call stack that we're looking at right now, what that actually looks like if you didn't have SOS. And I'm trying to remember what the call stack command is for LLDB. I mean, in WinDBG is K, but like BT, yeah, that looks to be it. So backtrace. What you're seeing here, all this gobbledygook that doesn't make any sense in terms of you looking at your .NET code, is the equivalent of the call stack that we got from SOS using the CLR stack command. Much more readable. As a matter of fact, it's, you know, you couldn't make sense out of this even if you, well, if you really tried, you could, but it would be nearly impossible. So what we have at this point is we've kind of figured out a crashing app. We can attach the debugger to it and do it live. Now, what is the problem with that? And the problem with that is in a production environment where your app is running and it's misbehaving in some sort or fashion, being able to live attach a debugger to that process and debug it. I mean, if you're lucky, you're like, your debug session is 30 minutes. If you're unlucky and it's a really hard problem, that could span days. In the meantime, as long as you have your debugger attached to that process is not running. So that is not an optimal solution in production. So the question is there anything we can do for .NET Core processes running in production that doesn't require us to attach a debugger to it to do our magic? So there's a couple of options, and the next step in that, I'm just going to exit out of LLDB, is that you can tell the .NET runtime to generate an artifact, which on Linux happens to be called a core dump, on Windows is called a memory or crash dump. So anytime that unhandled exception occurs, it will generate this dump. You can move it off the prod machines, or even on the prod machines, whatever the restrictions may be. But the point being is that you're not interfering with a live process by pausing it. You're simply looking at that artifact, sort of offline mode, and seeing what you can glean out of that to make it happen, or to make that bug appear. So one of the ways is to use kind of the equivalent of an environment variable in Linux. So the way that you tell the .NET runtime that you want to, oh, let me just go back, make sure. I'm gonna exit out of my little crashing app. There we go. The way that you tell the .NET runtime that you want it to actually generate a core dump for an unhandled exception is that you can use this cool thing, this environment variable. Com plus, now that might seem very incorrectly named for Linux people. DBG enable mini dump, and you set that to 1. Now when you run your app, we get the same thing, right? Press any key to run, but we're not going to attach a live debugger. We're just going to let the app run. We see the same thing. There's an unhandled exception. Something bad happened here. And we also notice running minidump. So this is the mechanism by which you tell the runtime, in case of an unhandled exception, do your job, and write out a core dump. And it so happens to be placed in this file here, which is temp and core dump, and 1761 is likely the process ID. So now we have this core dump. Mind you, the process, in this particular case, the scenario is simple in the sense that it's a console-based app, it crashes, it dies, right? But in case of server scenarios, oftentimes you'll have intermediate software that might be catching all the exceptions because you really like that process to stay up and be running. But now that we have that core dump, again, the equivalent of Windows crash dumps or memory dumps, how do we go about analyzing it? Well, we can use LLDB again. Again, it's similar to WinDBG. So we can run LLDB, and we're back in that initial prompt, and we can say target create and the path to the dump. All that says is, hey, you know what? I just ran LLDB. It has no clue if I want to attach to a live process or anything else. So he just kind of blindly sits there and goes, what do you want me to do now? So I'm telling it to create a target. And the target is a core dump on Linux, the one that we just generated. And it tells me that the core dump was loaded. So in theory, at this point, just like WinDBG, we can just issue the SOS commands that we are expecting. So I don't know, let's do CLR stack. What was going on when that exception was thrown? Well, it looks like our crash.program.main called into func, and that's likely what actually ended up crashing the app. And you can issue the PE command, which is print exception, the last exception that was happening on this thread. And we can see that it's a type system exception, messages bad thing happened here, and it gives you the call stack as well. So you can use LLDB to open up this particular dump file, core dump. Okay, so let me show you one more thing. If you don't want to install LLDB, perhaps you're on some Linux distro that does not support LLDB. Now, what do you do if you have a dump file, but you have nothing to open it with? So there is another tool, .NET tool install global, and it's called .NET dump. Don't want to sound like a broken record here. I already have it installed. Pretty straightforward. What you can do with this is you can run the .NET dump, specify a command, which is analyze, and then the path. Oh, where is my path? Oops. There's my path. Okay. So .NET dump, analyze, and the path to the dump. All this is, without having to use an external debugger like LLDB, is a .NET Core tool that allows you to issue SOS commands, which is pretty neat if you don't have access to a debugger. So here, I can do things like SOS help. Of course, it gives me all the commands that I can run. I can run CLR stack. Gives me the call stack of the thread that was actually crashing with that exception. And I can also run something like print exception, PE. And that gives me the exception details. So kind of to recap here, right? Your app is crashing. You can attach a live debugger. May not, or most likely is not the right thing that you want to do in a prod environment, but you could use LLDB and use all the greatness of the SOS commands that we have for debugging .NET Core applications. You can generate a core dump in the cases where your application needs to keep running, but there are certain things that happens in the app that you want to take a closer look at, like an exception. You can generate a core dump, and you can use either LLDB if that is available to you, or you can use this other .NET Core tool called .NET Dump to analyze it. So with that, now comes the big question. It is not, in production scenarios, it is oftentimes, I would actually say most of the times, it is not feasible for someone to issue commands to generate these core dumps, right? Imagine a scenario where your process is using intermittently, you don't even know when it happens, there's no pattern to it, but intermittently, it is using a little bit too much CPU than you expect it to, and you are tasked with figuring out what the problem is. If those spikes, those CPU spikes are very, very small, the chances of you getting on a prod box, issuing the right commands to generate a core dump for engineering to look at are pretty slim to none. So what you kind of need is a tool where you can tell the tool, hey, I want you to monitor this process. And when certain things happen, I want you to generate a core dump, right? Because that is the prime pristine opportunity to get the process out of state when it's at its worst. So looking at Windows, there are X number of tools. One of the more popular ones to actually accomplish this is called procdump, which allows you to do exactly what I said. It's basically you run procdump and you specify some triggers like if CPU goes above something, then automatically generate a core dump. Do we have something similar to on Linux? It turns out that we do. And the way that we've kind of done this is we've taken some of the tools out of the Sysinternals suite for Windows that we feel were very useful in the .NET Core context on Linux, and we've implemented those on Linux as well. So procdump, that is the tool to generate core dumps. Let's install it. It is a regular old package, and so all you got to do is just sudo apt install procdump. Once again, I already have it installed. If you don't, we'll just do it for you. No weird switches. And if you run procdump, you can kind of see a little bit about some of the options that we've got here, like -C, trigger core dump generation when CPU exceeds or equals specified value. Lowercase c is when the CPU is less than specified value. The same thing for actually committed memory. This is actually a recent addition as of, gosh, I want to say last Friday. You can also trigger core dumps to be generated when a thread count goes above a certain value and when a file descriptor count exceeds a certain value. So let's see how we can use procdump in our particular case. Once again, I'm just going to run my little crashing app. And much like pretty much all of the diagnostics tools, you have to specify the process ID of the process that you're interested in monitoring. So let's find out what that process ID is. This is our crashing app. So the process ID is 2218. And let's go back. So let's run sudo proc dump -p for the process ID, paste in what we just found, 2218, and we'll use the capital C switch, which is if CPU exceeds some threshold. And I'm just going to specify 10 here because I really don't expect my app to exceed 10%. Actually, let me backtrack on this a little bit because that is a CPU consumption, and the app that we're running is a crashing app. So let's go back to a more realistic app. Let's use our slow app again. .NET Run. Let's specify some argument. Okay. So this is the app that we're looking at before. It's just accepting requests, and it's taking 3 seconds for them to run. Now, maybe based on my triage stage before, I was like, you know what, CPU was more than 10%, which I'm not expecting. So let's go and get a core dump when that happens. I have to run the PS command again because we're not looking at the crashing app anymore. We're looking at the slow app. So that's the process ID. So let's run sudo proc dump -p for process ID and -C for whenever CPU goes above 10%, I want you to dump or generate a core dump. And what we can see here is that, press Control-C to end monitoring without terminating the process. So it's sitting here looking at that process continuously. And when CPU goes above what we specified, 10%, it will generate a core dump. And it will, as a matter of fact, also tell you that what the CPU was when that core dump was generated. So in production scenarios, when you want to specify triggers like memory triggers, CPU triggers, thread count triggers, file descriptor triggers, in scenarios, which is the most common thing in production, you don't know when the problem is going to happen, you just know the symptoms of it, you want to run proc dump because it will sit there and do this for you and just generate it when it happens. Now, this particular core dump, once it's generated, you can load it up the same way that I've showed you earlier. You can use LLDB, you can use .NET dump. So there's nothing different about this core dump. It's a pure, straight Linux core dump. Okay, so with that, kind of quickly go through because I've already talked through the summary of what we just did. Any questions on that second scenario when the app is crashing?
I'm checking, people. Anyone have a question?
All right. So, couple of quick things to wrap it up. I mentioned, just recently, right, is proc dump for Linux. Proc dump is part of a tool of a suite of tools called Sysinternals. That was created by Mr. Mark Russinovich on Windows and is heavily used because it provides a very easy way to diagnose things in production environments. We have started the process of moving those tools over to Linux. The first one, which I just showed, was proc dump. We started that back very late 2017. It is open source. So if you just go on GitHub and look for proc dump for Linux, you'll see it there. The other tool, after we sort of released proc dump and looked at what other tools that people will be interested in having on Linux, procmon came out at the top of the list. And so we've been working on the procmon side of things. And we are very close, month or two from releasing preview for Procmon on Linux as well. So if you're interested in those things, like I said, they're all open source. You can go and look at the code. If you want to contribute, even better. It's all out there. Very, very, very quickly. This is obviously, you know, is just, I think there's been a couple of previews maybe that's come out of this, but .NET 5, which is essentially .NET Core vNext. That's what .NET 5 is. And it's kind of intended to be, facetiously speaking, one .NET to rule them all. Using .NET 5, targeting Windows, Linux, macOS, iOS, Android, tvOS, watchOS, WebAssembly, and more. And it's kind of behind the scenes, the coming together of .NET as we know it today and Mono as well. So that's kind of the short, very, very abbreviated version of what's happening for .NET 5. I'm assuming that there's going to be some interesting work going on in the diagnostics area for this. We have obviously had .NET full for Windows for a long time. Ecosystem has got a lot of stuff in it. We got .NET Core running cross-platform. That ecosystem has been catching up rapidly. Now we fold this all into .NET 5, and we're only going to see more goodness happening in the diagnostics area. Just a few references. Again, Procdom for Linux, that's the GitHub URL. .NET Core debugging tutorial is something I wrote probably about 6 months ago. It's available on the diagnostics repo for .NET Core. And then there is the actual, you know, .NET Core diagnostics repo available here if you want to go and take a look at all the things. It's all open source, so available to everyone. So with that, I think we've reached the Q&A part of the show.
Okay, everyone, watch out. I'm unmuting everybody. So if you have questions, go ahead and just speak to them, because you're open mic now.
It's all live.
It's all live.
You're flirting with disaster.
I've always been a bit of a flirt.
This is a well-behaved group.
It is. I'm almost. No, I'm not going to say it. Anyway.
Disappointed. Guys, we need to step it up. Rich is disappointed that we weren't as rowdy as we normally are.
I can quickly change that, I promise.
Yeah.
I'm not sure what to make of that, though.
So Doolittle says, very insightful. Is there a cheat sheet for the commands and tools you use for the presentation?
That is a phenomenal question, because I have a pet peeve about that. So, you know, the
About
SOS
the question
commands.
being asked, or about the subject of the question?
The subject. If you just look at it from, like, you know, the commands that you can issue for SOS, there's plenty of kind of quote unquote cheat sheets out there that you can look at, and the fact that the SOS commands mimic the same behavior on Linux is a great thing. So those cheat sheets still hold the same. But I'm just going to throw my little thing in here. When you're looking at low-level debugging, such as, you know, getting core dumps or memory dumps and looking at SOS and stuff, to me, it's a little bit more about, like I can give you a cheat sheet of commands, and they're going to spew out a whole bunch of information.
Yep.
It's just really about, like, what is it telling you, right? And once you wrap your head around that kind of part of it, then you know, the output becomes just a lot easier to digest and things like that. But to answer your question, there are cheat sheets, and I mean, I don't have anything, unfortunately, in my slides here, but if you just, you know, Bing using Google, as Mr. Hanselman would say, then you can find those cheat sheets out there, and
Are there man pages?
That is a great question. I don't know.
I mean, that'd be the ultimate cheat sheet, wouldn't it? If you're already in Linux, you might as well just try it.
That is oh well. So great question. Let me pitch. I'm the dev lead for the Sysinternals for Linux. So let me just show that on ProcDump we do have one.
Woo!
And I wanted to lead with that because I don't know what's going to happen.
That's what the next one I was going to say.
Yeah. But that's actually that's great feedback. That's awesome.
Hey, let's
feedback.
add that on GitHub, and maybe a PadNug member wants to go get some cred for contributing.
Yeah, hell yeah, absolutely.
I tell people all the time, a great way to get some open source, get your feet wet with open source is just add the documentation.
Yep, absolutely. I mean, whoever's on the call and listening, go out and file this issue because that's a great point.
I was thinking, and by no means is this the only place, but I want to see some good method by which you can not have to know the PID going in.
Yeah, it's
And again, I'm saying that knowing full well that that's totally normal, but it's also always been.
I hear you. It's like I'm running. I don't know. I'm running this. I don't know, some web server, right? And what it does, it for whatever reason, I've designed it in a way that it just kind of forks up processes here and there, right? And then I'm looking at this thing because overall, from a user perspective, it's not behaving properly. And now I'm tasked with the notion of, well, which one of these processes is actually the one misbehaving? And unfortunately, like today, for this low-level type of debugging, there is nothing in there that kind of auto triages for you and attaches to the right thing and gets the right data. It's a great idea though, right? I mean, it's like, I want to be able to say, not on a particular process ID, but I want to be able to say, hey, my web server, no matter how many things it forks off, like tell me when something misbehaves, like over 10% or 20% or 80% CPU, and it just does it. That's, that would be great. We're not there yet though, unfortunately, but it's a great point. It's just kind of up leveling the thing so you don't have to do as much manual digging to find out what is what.
Chris typed a question that was, do you have any ideas on .NET 5 release dates?
I don't. Unfortunately, I don't. The only thing I have is.
Could you tell us if you did?
Well, I would gladly share any, sort of public information that we have. But I honestly, like, full on don't know. I know that there's been, I think, 2 preview releases. I don't know if you can still see my screen or not, but well, let's just
didn't it say something about release at the top?
Yeah. This is the actual, like, click here to get the bits. So
yeah.
I don't. Oh yeah. So this was, what is it? The 7th today. So 5 days ago, preview 2 came out. Preview 1 was, I don't know, like 3 weeks ago or so. But this would be the page that I would kind of keep monitoring to see, and at least in terms of like, here the bits are available. Yeah. It'll be interesting though. Like,
oh, wait, you know what? We intend to release .NET 5 in November of 2020.
Yeah. Okay.
Yep, that's it. It says that.
Okay.
Yeah, that is actually, that first page you went to actually does mention that just below that first picture.
No, not this one.
which was the dev blogs link.
Oops. Oh, here we go.
See that first paragraph, second paragraph after the picture? We intend to release .NET 5 in November.
Yeah.
Of course, this was posted May 6th, 2019. Things may have changed since then, but
May have. If anything, it sounds like it's pulled in.
Yeah, no, I mean, I think, you know, this is a good blog to go and look at. It's Richard Lang. And, you know, we've already had a couple of previews coming out. We're at like almost mid-April or whatever. So, yeah, absolutely.
Chris
Now,
also asked, does that mean no more need for mono?
No more need for mono?
Chris, why don't you unmute and expand?
So I
kind of see it on that page. It says taking the best of .NET Core, or taking .NET Core and the best of mono. I just wonder if that's going to end up becoming just like a replacement for the mono.
I don't know. That is the clearest answer I can give you. Yeah. Not sure if that short answer helps or not. The idea behind .NET 5 is that as an end user or end developer, right, you don't have to worry about whether or not you're using mono or .NET or .NET or whatever the case may be, right? It's all kind of being unified. And it's not just like, hey, we're just kind of trying to do it because mono is this kind of the separate thing. No, this is really, really all of it coming together. So I don't know if that helps or not. I am not part of the .NET Core team. My specialty is around the diagnostic side of things. So I can't really, necessarily speak definitively about the internal decisions or whatever that's happening there. But I will say one thing: it is going to be interesting from a diagnostics point of view, right? It is going to be interesting to see, because if you look at .NET, whether it's full or core and then mono, they're both core. They're both .NET CLR implementations, but obviously those implementations differ on the surface. They look the same. So I am very curious and integrated into the notion, the whole aspect of how do we make that come together also as a diagnostics story, because that's, hugely important. I don't know if that helps, but hopefully it does.
Let's see. I saw one. Carl asked best debugging tips. First steps to debugging Windows every dev should know. Carl, is that more of a question of where to find resources, or is it?
Just any tips that you can provide. Quick tips.
Good question. That's a really good question. So my first question there would be, are you looking at debugging sort of like in your day-to-day dev work? Or are you looking at debugging in production?
More for like desktop apps when they crash.
Okay. And those crashes, like, the desktop apps being like something like when you're doing dev work, or when it's those desktop apps are like running in the wild somewhere?
Dev work.
Dev work. Okay.
Yeah.
In those cases, I would utilize the easiest tool possible, which would be Visual Studio. Like, full stop.
Oh, sorry, Bill. Turning it off and back on is not the answer.
And then if you're looking at like, hey, we've shipped our desktop app to millions of customers, and some of them are experiencing like these intermittent issues somewhere, that's when you really got to think about like, how do I get the right data at the right time from that user's machine so that I can debug it post-mortem, because you can't, it becomes really, really hard to take an arbitrary user and say, well, let me just slap Visual Studio on it and do my magic, right?
Right.
So those are two very, in my mind anyway, those are two very different workflows. On your dev machine, you're developing the product, or you know, running unit tests, whatever. Use the best. Visual Studio will shine bright in those areas. But when it gets out into the wild, it gets a little trickier to get the right data. And the right data is oftentimes a combination of a tool that will give you the right data at the right time, and that output of that tool is post-mortem diagnostics data, like in the form of a dump file or profiler. You got to move those files back home and then use some of these low-level tools to actually figure out what's happening.
Okay, yeah, so you're talking the tools that you mentioned tonight. Proc dump.
Yep, proc dump, .NET Trace, .NET Dump, all of these tools.
Okay.
Will become important. Yeah.
Hey, Ron. I'm sorry, Mario. Ron asked, do you know if the crash dumps you showed can be used in the debug diagnostic tool, or is that just for Windows?
Debug diagnostics is Windows only.
Okay.
For now, they're Windows only.
And let's see, Lee wants to know, do you know Mark Downey?
Yes, I do.
Because Lee worked with him at Fiserv. Go ahead, Lee, if you want.
Oh, I just was throwing that out there because it's the same kind of debugging stuff that he used to be really experienced at, and I think is what he's doing over at Microsoft now.
Yep. He's in the Visual Studio team. I've worked with him. I mean, we continue to work with each other, but I've worked with him pretty closely in the last 6 to 12 months. Yeah, absolutely. He's got a ton of experience. He's a good guy. Good guy.
You know what I find fascinating is we're wrapping up about the time we normally would wrap up our meetings.
Uh-oh.
No,
is that
that's
bad?
awesome.
Okay. Stand your throat, Mario.
I'm pretty surprised and pleased. We unfortunately don't get to go drink after this, but yeah, you can. Yeah, there you go. What you got there? Which IPA? Deschutes Dead Man or something?
It's Fresh Haze. No, yeah, Fresh Haze. It's really good.
Nice. Welcome to the world of IPAs.
They call it Beervana for a reason.
Ketterman thinks he won. Anyway, yeah, we don't have a lot of swag to go tonight, so it's all whatever you took away from this is your swag.
The swag was in you the whole time.
That's right. That's right. Well, Mario, I really, really, really appreciate you being our first virtual presenter at PadNug.
Oh, absolutely. Thanks for having me.
Everyone can unmute and cheer. Go, go. Woo!
Hopefully once this madness is over, maybe we can do it in person next time.
Well, it sounds like there's more subject matter.
Yeah, for sure.
we just between some of the questions and what you presented, there's definitely going to be. Oh, Patrick, I think that was you, and I couldn't quite hear you. Oh, in any event. All right. Well, I will. It's come up a couple times, and I don't know for sure how we will publish. First step will be I'm going to see if I can grab the content and send it to the YouTube channel. That'll be the best option. And then if that doesn't work, I'll share the link to the presentation on what's this called? Zoom. Of course, the problem is that's tied to my personal account. Not worried about that, but if I were to leave or not be hosting that account anymore, then we might run into some trouble. So I really prefer to get it to YouTube, so I will do my best on
that. I do have a question though, Rich.
Yeah, go.
There is a yellow sign behind you, and part of it is Yeah.
Yeah, that one.
Yeah,
That
that's
right
the
there?
one. I was wondering about that one.
It says exactly what you think it does.
All right, cool. I'm just making sure.
What you may not realize is I did go through a little bit of a triple bypass last fall.
Oh,
And
shoot.
that was one of the things that there is someone involved in that card is on the meeting right now, but I will not identify directly.
Well, I'm glad you're doing all right.
Well, it's my constant reminder back there.
Yeah.
But I also keep the other card from my sister in front of it just in case I'm on a video conference and someone is easily offended. But you caught that one perfect, Mario. All right, folks. I don't think there's much else to say. There's probably about a 50-50 chance we're going to do this next month with Doolittle. So
I think we should just plan on it. I mean,
say again.
Let's just plan on it. I mean, unless there's some
right now, I am planning on it. The flip is maybe that's not the right option, or maybe we do a hybrid and do it this way, and people who can make it out to the venue can be there that way.
That would be interesting to explore that as well. Yeah, we haven't heard from James at all. At least he didn't get to do it.
You gotta say something,
stick.
Mr. Scheit.
I see him.
I'm going to unmute you, James, so you can say something to us.
You love the power, don't you, Rich?
I know. Oh, did he already mute himself back up? He got himself so he can't unmute him. What a thing.
Ooh, he shut you down.
Son of a gun. How do you do that? You got to do the swag part, James. Anyway.
Well.
All right, folks. It's been awesome, and stay tuned, and we'll figure out how we're going to share the video with the world.
Awesome. Thanks, everyone. Thanks for having me, and stay safe.
Thank you. Have a good one.
Thank you, everybody.
And you.
And they drop like flies.
Bing, bing, bing,
Ah.
Bing, 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 bing.
Can't get rid of me that easy.
Stay on so long enough for everyone to leave by their own power. So
that's right.
Except for these two who are probably going to be here way longer than I expect.
Oh yeah.
I'm pointing at Jeff and Hunter when I say that. By the way, everyone, and especially with the group here, Bill Stanford is probably, this is his last time, is it, until we do virtual again?
Yes, I'm taking off on Monday.
Jeez.
Are you flying?
No, I'm driving. I've covered my car in barbed wire and guns, so I should be okay.
Yeah, there you go. Hope you got lots of ammo.
Prepare for the apocalypse.
I'm going through Idaho and Wyoming, so I should be able to find plenty if I run out.
Ooh.
No. You won't be able to find it because they'll all have it. They won't let you get to it. Get off my land.
Just don't stop.
How long are you going to take to get there, Bill?
Open season on Oregon Plate.
5 or 6 days. Depends on whether I stop to see a friend of mine along the way.
There's a lot of stuff to stop and see. I don't know. I think I'd take 2 weeks at least.
I don't have that much time to spare.
Oh, well. Hey, Scheit, you unmuted yourself. Say something.
Hey, how's it going? Good guy, good speaker. I liked him. I thought he was really perfect for this kind of venue.
I find it fascinating that you wait till there's only like 10 people left.
Rich, not everyone's an extrovert like you.
Voicing an opinion. He seemed to have a lot of experience.
Yeah. No, I thought that really well. I did.
I'm curious, a terminal-heavy presentation like that to a .NET community was like a no way in hell just 3 years ago.
Yeah.
And I'm curious how many people are still, not in like .NET New Land and using a terminal or WSL, because it seems like, inside Microsoft, there's been a massive shift in that direction. And I'm curious, and I don't know, maybe none of us really know, or if we do, it might be anecdotal, but, a lot of my experience, especially in the late, mid to late 2000s and even the earlier parts of this decade, or I guess the last decade, people were still very locked to a GUI, and any notion of using a command line was just not the .NET way. I don't know, what do you guys think?
Well, or the Windows way. I know I come from a command line background, and when I'm at work and I go to a DOS box and I do a dir, and I do a dir/s, for subdirectories or something, people, oh, what are you doing? It's still common. So it doesn't seem weird to me, but I think there's like a lost generation, right? Where there's, people just never had a reason to go to the command line, and now they do again.
Yeah.
But I always found it frustrating to always have to be in a UI and picking around and clicking around and stuff.
It feels slow. Well, so that's why they give you macros, right? Then you don't need a terminal. You just record macros.
So now we got these 8 or so people here. What worked well? What didn't? Any suggestions on what we do different next time?
Well, I just do want to point out before you say there's 8. So there's 2 Riches and 2 Hunters. So, just so we're totally clear on that right now.
That's why I didn't say 10. I counted, Jeff. I did.
You actually counted? Okay, I'm proud of you.
Here, I'll fix one of those right now.
Which one you fix?
Oh yeah, turn off the recording before we start talking.
Oh,
no, too late. This is all